Nikola Tesla's dream of extracting electrical energy from air is one of the most intriguing aspects of his legacy and futuristic vision in the field of electricity and engineering. Tesla, a prolific inventor and scientist, pioneered numerous technologies and concepts that laid the foundation for the modern world of electricity, telecommunications, and energy. Welcome back to the channel. Make sure to stay until the end of the video where we will discuss how this discovery came about and the impact it will have in the future. The idea of extracting energy from the air originated in Tesla's belief that the world was full of free energy available for unlimited harnessing. Tesla imagined that the Earth's atmosphere, charged with electrically charged particles, could be considered a vast reservoir of electromagnetic energy ready to be captured and utilized. One of the key concepts in Tesla's dream was the use of electric and magnetic fields to induce electric currents in the atmosphere, which could be captured and channeled into receiving devices for practical use. Tesla explored the idea of creating wireless power transmission and reception towers that could communicate with each other via electromagnetic waves, without the need for conducting wires. One of Tesla's most famous proposals was the construction of the Wardenclyffe Tower, an ambitious project aimed at transmitting electrical power over long distances using the principle of electromagnetic resonance. Although the tower was never fully completed due to financial, technical, and political problems, it represents Tesla's bold vision of a global wireless power network. The competition to develop clean, renewable sources of electrical power is a highly relevant issue in today's context. With growing awareness of climate change and the imperative need to reduce greenhouse gas emissions, it has become increasingly clear that reliance on fossil fuels is not sustainable in the long term. This focus on the pursuit of renewable energy sources is not only motivated by the urgency of addressing climate change, but also by the need to achieve energy independence. The ability to generate electricity from renewable natural resources offers a more secure and sustainable alternative to fossil fuels, whose availability and price are subject to geopolitical fluctuations and resource constraints. Exploring renewable energy alternatives has become a global priority. Technologies such as solar, wind, hydro, geothermal, and biomass are constantly being developed and improved to make them more efficient, affordable, and accessible. These renewable energy sources not only offer a way to reduce carbon emissions and mitigate climate change, but also present opportunities to diversify the energy mix and promote energy security. The recent discovery of electricity generation from air humidity was the result of a chance accident in the laboratory at the University of Massachusetts Amherst. In May 2023, a team of researchers led by Professor Jun Yao was developing an air humidity sensor using nanostructures. During the process, a student forgot to plug in the sensor, but to everyone's surprise, it produced an electrical signal even when it was unplugged. This unexpected incident led the team to investigate further and discover the potential of nanostructures to generate electricity from atmospheric moisture. The nanostructures used in the sensor consist of microscopic tubes or nanowires with a thickness of approximately 100 nanometers, which is considerably thinner than a human hair. The operation of these nanostructures is based on their ability to allow water molecules present in the air to enter freely through the small holes present in them. When these water molecules collide with the edges of the holes, a phenomenon known as deprotonation occurs, which generates an electrical charge in the nanostructure. This electrical imbalance between the layers of the nanostructures causes the ends to become positively and negatively charged, thus creating a potential difference that can be used as a source of electricity. This accidental discovery represents a significant breakthrough in the field of renewable energy generation, as it takes advantage of a widely available resource such as moisture in the air. In addition, the research team continues to explore different materials and techniques to improve the efficiency and scalability of this technology, which could have important implications for the development of devices that can harness atmospheric moisture as a clean and sustainable energy source in the future. Research on electricity generation from air humidity has seen significant advances, opening new perspectives in the field of renewable energy. This innovative approach is based on the ability to harness atmospheric moisture, an abundant and widely available natural resource. In addition, efforts have been made to improve the efficiency and scalability of this technology. Researchers are exploring new fabrication techniques and device design to maximize moisture capture and electricity production. This includes optimizing the structure and composition of the materials used, as well as exploring different device configurations and geometries. Another important aspect of research in this field is the development of practical applications for the generation of electricity from moisture in the air. A number of potential applications are being explored, ranging from portable devices and standalone sensors to power systems for electronic devices and small household appliances. Do you think that this way of generating energy will be relevant in the future, or do you consider that there are better ways of obtaining energy? The Lupchik family, consisting of Professor Splaine Lupchik and her twin sons, Professors Andrei and Serge Lupchik, has been instrumental in the development of hydropower technology in Portugal. Their work has focused on researching and developing methods to harness atmospheric moisture as a renewable and sustainable energy source. Since 2015, the Lupic family has been committed to this innovative vision, long before the idea gained popularity or widespread acceptance in the scientific community. Through their dedication and effort, they have significantly advanced the understanding of how moisture in the air can be harnessed to efficiently generate electricity. The impact of their work on the development of hydropower technology has been remarkable. They have helped to establish the scientific and technical foundations needed to advance this area. In addition, their work has inspired other researchers, companies, and entrepreneurs to explore new possibilities in the field of renewable energy. As for the potential applications and advantages of hydropower technology, these are diverse and significant. Potential applications include electric power generation, energy autonomy, complementarity with other renewable energy sources, and reduced environmental impact. In summary, the work of the Lupchik family in Portugal has been instrumental in advancing the development of hydropower technology, opening up new possibilities in the field of renewable energy. The potential applications and advantages of this technology are diverse and promising, and could have a significant impact on the transition to a more sustainable and energy-independent future. Hydropower technology faces a number of scientific and economic challenges that must be overcome to reach its full potential. First, one of the key scientific challenges is to fully understand the process of generating electricity from moisture in the air. Although significant progress has been made in this field, there are still unknowns about the precise mechanisms involved in the interaction between nanostructures and water molecules. Understanding these processes at the molecular level is crucial to optimize the efficiency and energy production of hydroelectric devices. In addition, the economic feasibility of hydropower technology remains a major challenge. Currently, the production and scale-up costs of hydroelectric devices can be prohibitive, limiting their large-scale adoption. The development of cheaper materials and optimization of manufacturing processes are key aspects to reduce costs and improve the economic viability of this technology. Another challenge related to economic viability is competition with other renewable energy sources, such as solar and wind. While hydropower technology offers certain advantages, such as continuous power generation and the ability to operate in all weather conditions, it must demonstrate its competitiveness in terms of cost and efficiency to attract investment and be widely adopted. In terms of potential future developments, research is expected to continue to advance in key areas, such as the development of new materials and the optimization of manufacturing processes. Advances in understanding the mechanisms of electricity generation could lead to significant improvements in the efficiency and performance of hydroelectric devices. In addition, scaling and commercialization efforts are expected to help reduce costs and increase the long-term economic viability of hydropower technology. As scientific and economic challenges are overcome, hydropower technology is likely to play an important role in the transition to a more sustainable and diversified energy system. The potential for hydropower technology to revolutionize power generation is considerable. With its ability to harness an abundant and ubiquitous energy source, its reduced environmental impact, and its potential for scalability, hydropower could play a key role in the transition to a more sustainable and diversified energy system worldwide. Thank you very much for staying until the end of the video, my friend, and if you liked the video, give it a thumbs up and subscribe to make sure you don't miss any of my videos.